Intermediate Algebra Section 1.6, we're going to take a look at simplifying some algebraic expressions and simplifying them without negative exponents. So within the parentheses, we have multiplication, and parenthesis next to a parenthesis is multiplication as well. So similar to what we've done in the past, using commutative property, we can rearrange the order of multiplication and still maintain equality. So cutting and pasting and rearranging, sorting so that we have similar terms next to one another. We have common bases multiplied, which means we can add the exponents. -2 plus -4 is -6. B here is to the first common bases, add the exponents. -3 plus 1 still leaves us at a negative, and this would be to the first power. So common bases add our exponents is c to the -4th power. In addition to simplifying, they also want to have us express our answer without a negative exponent. So each one of these has a negative exponent, so to eliminate it, they'll each go to the denominator multiplied together. So we would have a 1 over a to the 6th times b to the 2nd times c to the 4th power for an equivalent expression. In this next example, we have a power rule application where when we have a term with an exponent raised to a power, we multiply the exponents together. If we remember the rule, it's pretty straightforward. It's x to the 6th times 5 or x to the 30th power. If you're in question, as long as you understand the concept of what an exponent means, in this case we have something raised to the 5th power, that something is x to the 6th. So in expanded notation, this would be 5x to the 6th power multiplied together. We now have common bases multiplied together. You'd add your exponents, 6 plus 6 plus 6 plus 6 plus 6 would give us 30. And if that didn't click in, you could write the 6 x's for each one of them and add them up to give you x to the 30th power. Now in this problem, we didn't have to worry about eliminating a negative exponent. In this next example, we have a quotient raised to a power. You have a couple options on simplifying this. You can simplify inside the parenthesis first and then raise each term to the power. And if we're following order of operations, we clearly could do that. Or we could eliminate this outer parenthesis by raising every term in there to that power. As long as we follow principles of exponents, there are multiple ways to simplify. But let's go with order of operations. We have common bases where we can combine our common terms with exponents. And inside the parenthesis, we have a 2, so there are no other integers. We'll leave the 2. We have common bases where we can subtract our exponents. So we'll have x to the top power, -3, minus the exponent in the denominator, times common bases with our y's, y to the first minus the exponential power in the denominator of 3. Simplifying, and this is still to the -2nd power, so we have a 2. Minus a minus is a plus. That leaves us with x to the -3 plus 4 or first power. And if you switch these to eliminate the negative, the x to the 4th would have gone to the top, the x to the -3rd would have gone to the denominator, and 4 minus 3 would give us the 1. So if that helps illustrate what was happening with the x's. On the y's, we have 3 y's in the denominator. This 1 y will cancel out, leaving y to the 2nd in the denominator, and we can see that When we subtract our exponents here, 1 minus 3 leaves a negative 2, which if we don't want the negative exponent, would put it in the denominator. So it's looking good. Now what we have is a product raised to a power. That means each one of those factors is raised to that power. 2 is to the negative 2. X to the first is raised to the negative 2, whether you put the 1 or not. And y to the negative 2 is also raised to the negative 2 power. So each one of those three factors is raised to the negative 2 power. 2 to the negative 2, to eliminate that negative, we'll put it in the denominator. So we put a 2 to the second in the denominator. X to the first, a power raised to a power. 1 times negative 2 is negative 2. So we have an x to the negative 2. And to eliminate that, we'll put it in the denominator. And the third one, a negative times a negative is positive. We end up with a positive y to the 2 times 2, or fourth power. Again, this term here would have simplified to an x to the negative 2 is why it went to the denominator. And the final simplification would be to simplify here. 2 to the second power, 2 times 2 is 4 in the denominator, along with the x squared that we already simplified. In this next problem, we have order of operations that we do need to follow first. Before we do division, we have a product raised to a power. That means each one of those terms is raised to that power. M to the third is raised to the negative 1. The second factor, n to the fourth, is raised to the negative 1. And in the denominator, these three factors are raised to the second power. So we'll take care of our exponents first by raising each one of those terms to the power. Simplifying here, we have a product raised to a, not a product, we have a power raised to a power, so we multiply exponents. 3 times negative 1 is negative 3. 4 times negative 1 is negative 4. Negative 3 to the second power means negative 3 times negative 3, which is 9. Here we have a power raised to a power, so we multiply exponents with a negative 4. And same thing with the n. 5 times 2 leaves us with an n to the 10th power. Whether you subtract your exponents or you move your negative exponents, it's kind of 6 of one and half a dozen of the other, your choice. If we eliminate the negative exponents and simplify as our option, that means these two terms will go down, this term will go up. So we have an m to the fourth migrating to the numerator from the denominator. The 9 will stay put. M to the third goes to the denominator, and to the negative fourth goes to the denominator, making it positive, and n to the 10th stays put. Combining these using the quotient rule might have been a choice that you opted for over this one. What we now have is common bases in a quotient situation where we will subtract exponents. And here we have common bases multiplied together where we add exponents. So for our final simplification, we will have 9 in the denominator, but taking the quotient, we'll subtract our exponents. And since we have common bases in the denominator, we will add the exponential powers, which leaves 4 minus 1 is m to the first power, or just m. 9 common bases, add our exponents, leaves an n to the 14th power.